Hello everyone, my name is Imani Vishwakarma and this is our sixth video series of data science. In this series we learn about naive Bayes classification. What is naive Bayes classification? A family of algorithms based on Bayes theorem despite the naive assumptions or features independent. These classifiers are widely utilized for their simplicity and efficiency in machine learning. In this, the applications seeded light on their particular utility despite our simplified assumptions. What is naive Bayes classifiers? Naive Bayes classifier are a collection of classification algorithm based on Bayes theorem. It is not a single algorithm but a family of algorithms where all of them share a common principle. Every pair of features being classified and independent of each other. To start with, let us consider a data set. Why it is called naive Bayes? The naive part of the name indicates the simplifying assumptions made by the naive Bayes classifiers. The classifier assumes that the feature used to describe and observations are conditionally independent given the class level. The Bayes part of the name refers to relevance Thomas Bayes, an 18th century statistician and theologian who formulated Bayes' theorem. Assumptions of naive Bayes. The fundamental naive Bayes assumption is that each feature makes and feature independence. The feature of the data are conditionally independent of each other given the class level. Continuous features are normally distributed. If a feature is continuous, then it is assumed to be normally distributed within each class. Discrete features have multinomial distributions. If a feature is discrete, then it is assumed to have a multinomial distributions within each class. Features are equally important. All features are assumed to contribute equal to the predictions of the class level. No missing data. The data should not contain any missing value. Now we learn about Bayes' theorem. Bayes' theorem finds the probability of an event occurring given the probability of another event that has already occurred. Bayes' theorem is stated mathematically as the following equations like A like P of A by B, which is equals to PB by A P A by B, which is equals to P of B by A and P of A, where A and B are event and P of B is not equals to 0. Basically, we are trying to find probability of event A given to event B is true. Event B is also termed as individual. Event B is also termed as evidence. P of A is a prior of A, the prior probability. Probability of event before evidence is seen. The evidence is an attribute value of an unknown instance. It is an event B. P of B is marginal probability. Probability of evidence. P of A by B is a posterior probability of B. Therefore, probability of event after evidence is C. P of B by A is likelihood probability. The likelihood has a hypothesis will come true based on the evidence. Thank you.